Hey everyone, welcome to our Winter 2026 ENCMP 100 Programming Contest submission. We're James and Marcus, and we're presenting the hike recommendations map under the applications category.
The short version of what this does, you type in your city, pick a date, set your trail preferences, and it drops a pin on an interactive map showing you the best nearby hikes based on tomorrow's actual weather forecast. Click any pin and you get the distance, the forecast, some plain English advice about whether it's actually worth going.
What's cool is that this just started as a basic script that just printed text to a console. So let's walk through how we got here.
The first version had zero visual polish. It was purely about getting the logic right.
We started by cleaning up our CSV database of hikes, making sure the data was consistent enough to actually work with. Then we wrote out our core distance calculator using the Haber-Sign formula. The reason we needed that instead of basic geometry is that the Earth is curved. Well, most people think it is. So straight line math gives you wrong answers over meaningful distance.
We used Python's built-in math module to implement it, and it calculates the exact distance between the user's location and every trail in the database.
At the end of version 1, the program just printed a sorted list of nearby hikes in the Spider console. Not pretty, but the math worked. And that's what mattered at that stage.
Version 3 was the biggest shift, and honestly, the most fun to build.
We realized pretty quickly that a ranked list of trail names printed in a terminal is a weird way to present geographic data. So with our professor, Dr. Jin, he recommended making a map. So we decided to do that because you can't really picture anything with just a little output file. The front end picks that up with a JavaScript fetch call and uses a library called leaflet.js to plot everything as pins on an interactive map. It's the same core logic from versions 1 and 2. We just changed what happens to the output at the end. We would now like to take the time to do some acknowledgements for the people and the agents that helped us do this project. First of all, we got my uncle, who's a data scientist. He taught us about APIs, how to query, and then how to get that data and implement it into our program from the API. So a big thanks to him. Also thanks to Claude for making the giant CSV file. I think it was about 750 hikes right at the end. So I didn't really want to type all that in, so thank you to Claude for that.
Thank you to Dr. Jin for recommending to use a front end with JavaScript to try and visualize all the hikes. Thanks to Gemini for teaching me the JavaScript, because that wasn't happening otherwise.
Yeah, we didn't learn that one in class.
What is Flask? I still don't know, really.
Well, we learned a lot of stuff, and it was a lot of fun, so.
Looking back, building this in stages was really the right call. Before using the CSV file, we opted for an API to find the hikes. This didn't really work because it would take a long time for it to parse through and find hikes. And it would also be unvetted hikes where they would be biking trails or maybe fire roads. So it was much better just to build our own database and operate from there.
And getting the ranking algorithm solid in version 2 meant the Flask transition was mostly just about presentation, going from that output in the console into the actual map. The hard stuff was already done.
Hopefully this gives you a good understanding of what Python can do when you start stacking pieces together. Thank you for watching.